Hey class, today's lesson is on atomic structure. Did you know that in one drop of water there are about 6 sextillion atoms? Look at that number on the screen. That is huge. Atoms are microscopic. They are tiny, tiny particles. All matter is made up of atoms. Atoms are all around you in the world. And today we're going to learn what an atom is made up of and what it looks like. So everything that exists is made of atoms. All matter is made up of atoms. They're super, super small, microscopic. That's why even a small object contains thousands or millions of atoms. Atoms are made up of subatomic particles. There are 3 of them. Okay, 3 parts. This just means an atom is made up of 3 parts. And today we're going to learn about those parts: the proton, the neutron, and the electron. Let me just show you a brief idea of what an atom looks like. So here I'll write atom. So inside of an atom, you have a nucleus. Okay, so this first circle is called the nucleus. And inside the nucleus, you're going to find 2 of your subatomic particles. You're going to find your protons. I think I'll be able to fit this. And you're going to be able to also find your neutrons. Okay, so both protons and neutrons are found inside of a nucleus. And think of a nucleus like the jail of an atom. Nothing can escape the nucleus. So protons and neutrons are stuck inside the nucleus of an atom. Outside of the nucleus, you have rings that we call electron shells. Okay, and on these rings, you are going to find your electrons, and electrons are drawn with, or as symbols with just filled in circles. Okay, so you have protons and neutrons inside the nucleus, and you have electrons that float outside the nucleus on these shells. So the subatomic particles are all different from each other based on their electrical charge, their symbol, and where they're located inside of the atom. Let's look at the proton first. So we already know, I'll draw you a quick, okay, we know we have our protons and our neutrons inside of our nucleus, and then we have our electrons, okay, on these shells, right? So protons are positively charged, and you're going to remember this because P for proton, P for positive. Okay, the symbol for a proton is the letter P with a plus sign, and they are always found in the nucleus. They never leave. The number of protons stays the same always because they can never escape the nucleus, so that number is going to stay the same. Your next subatomic particle is the neutron, and again, if I draw this, you have your proton plus, you have your neutron, neutral, and then you have your electrons, right? Okay, so neutrons, N for neutral, they have no charge, okay? The symbol for a neutron is N with 0, this means no charge, and they are found inside the nucleus with the protons. Lastly, you have your electrons. Your electrons have a negative charge. The symbol for electrons is the letter E with a negative sign, and they orbit around the nucleus in shells, okay? In those electron shells. There's also an arrangement of how many electrons can be on each shell. So you might have noticed that, so here's my nucleus. My first shell I was drawing only had 2 electrons only, ever. So only 2 electrons can fit. Your shells will look way nicer than this. Your second shell can have a maximum of 8 electrons on it. And the number is going to come from the periodic table, and we'll talk about that in a second. So just to go over everything, an atom is made up of 3 parts. Okay, protons, neutrons, and electrons. The protons are positively charged particles. They're found inside the nucleus. Neutrons are neutral. They have no charge, and they're found inside the nucleus as well. And the last part of an atom is the electron. They are negatively charged, and they actually move around on shells outside of the nucleus. Okay, so here again is another diagram of an atom. So you'll notice inside the nucleus you have protons and neutrons, and outside the nucleus on rings you have electrons. Now, if you'll notice, this is a diagram of the periodic table. These are all the elements that are found naturally in the world. Please pay attention to these numbers. This is called the atomic number. You are going to notice that the periodic table is arranged from lowest atomic number of 1 to highest atomic number of 110. That atomic number tells us very important facts about the subatomic particles. Every element has its own unique atomic number. No two elements have the same atomic number. So that means no two elements are exactly the same. So that atomic number represents the number of protons in the nucleus. So this becomes really important when you want to be able to represent the elements on the periodic table, because you need to know the protons, the neutrons, and the electrons. So where are you going to get these values from? Well, the atomic number, it's always found at the top left or the top right of the periodic table. Depends on the periodic table that you're looking at. It tells you the number of protons, and by default will also tell you the number of electrons in a neutral atom. All the elements on a periodic table, as they are on the periodic table, are neutral. Neutral means that you have the same amount of positive charge that you have negative. We learned this in the electricity unit. So same positive and negative. That's how you balance out the charge and have no charge, right? So if the atomic number tells you the number of protons, then if the element is neutral, as all elements are on the periodic table, then automatically, if you know the number of positive charge, you know the number of negative charge, because they're going to be the same. If you're confused as to which of the two numbers on the periodic table is the actual atomic number, the smaller number is always the atomic number. The bigger number is the atomic mass, and we're going to learn about that in a second. So that atomic mass, which is found at the bottom usually of your element symbol and is always bigger than the atomic number, that is going to tell you the number of neutrons, but it's not going to be immediately evident. You're going to have to do a little bit of a calculation. So the number of neutrons that an element has can be calculated by taking the atomic mass and subtracting the atomic number. So if I was doing this for beryllium, what would it look like? It would look like the atomic mass of 9, and you can always round it to the nearest whole number. So 9.01 rounded is 9. 9 subtract 4 is going to give you 5. So beryllium has 5 neutrons. Okay, so if I was to show you that, it would be 9 subtract 4, which is equal to 5. So beryllium has, because of the atomic number, it has 4 protons, and by default that means it has 4 electrons, and it's going to have 5 neutrons. And I know it has 5 neutrons because I did this calculation down here. You take the atomic mass and you subtract it from the atomic number. Okay, and we just did this. So the number of protons would be 4 because of the atomic number. The number of electrons would be 4 because of the atomic number. Okay, so this comes from the atomic number, and this comes from 9 subtract 5. Which is equal to 4. Okay. Let's try the next one. Determine the number of protons, electrons, and neutrons in an atom of sodium. So again, let's just make sure everybody's on the same page. This is the atomic number. This is the atomic mass. Atomic mass is always bigger than the atomic number. Okay, so the atomic number is going to, by default, tell you the number of protons, which will also tell you the number of electrons, because for a neutral element on the periodic table, and I'm being specific to say on the periodic table, because not all elements are always neutral. They will become ions, which we'll learn about in our next lesson. So be careful when I'm saying elements are neutral. It's only the ones that are found on the periodic table as they are. Okay. And then to figure out the number of neutrons in this sodium atom, we are going to take the atomic mass and we are going to subtract the atomic number. So let me show you what that would look like. 22.99 is our atomic mass. If we round that, it's going to be 23. So 23 subtract 11 is going to equal 12. So sodium has 11 protons, it has 11 electrons, and it has 12 neutrons. Okay, now let's try some practice. So how many protons are in a zinc atom? So if you are looking at your periodic table, you would see that zinc is number 30 on the periodic table. So I'm just going to write out its symbol. So zinc, it has an atomic number of 30. It also has an atomic mass of 65.4. So I'll write that down so we all have that information. Now, the question's asking us for how many protons in a zinc atom. So remember, protons comes from the atomic number, right? So how many protons does zinc have? Your answer should be 30 protons. And let's just practice everything. If zinc has 30 protons, then it will also have 30 electrons. And then how many neutrons would it have? Well, what's 65 subtract 30? I hope you said 35 neutrons. Okay, let's try another example. How many electrons are in a strontium atom? So let's find strontium on the periodic table. It is atomic number 38. So strontium, that's its symbol. It has an atomic number of 38 and an atomic mass of 87.6. So how many electrons are in a strontium atom? Well, we are going to get that from the atomic number. So there are 38 protons, which means there are also 38 electrons. And then neutrons is going to be your atomic mass, subtract your atomic number. So that would be, this will get rounded to 88. So we're going to do 88 subtract 38, which will give you 50 neutrons. Okay, let's try one more. How many neutrons are in a nitrogen atom? So if you're looking at your periodic table, nitrogen has an atomic number of 7 and an atomic mass of 14. So that means 7 protons, 7 electrons, because that comes from the atomic number. And then this one is unique because it also has 7 neutrons, and that comes from 14 subtract 7 is equal to 7. That doesn't always happen, that your 3 subatomic particles are the same number, but it can happen. Okay, now you can pause the video and you can try these ones on your own. If you have any questions, feel free to email me. If you don't, you can start the practice now.